So just remember, while if you are say going by 1, 2, 3, 4, group 1 will have 1 electron, group 2 will have 2 electron. Just remember that group 3 will not have, group 13 will not have 13 electrons. So since we are not considering, we are going only in the upper part of the periodic table where the transition elements are not coming into picture. That is why the group 13 will have 3 electrons, because it comes directly after group 2. And so group 14 will have 4 electrons, and if it has 4 electrons, its valency would be 4. Simple. And then what is its, then they'll give you the period number, and then they'll ask you how many shells does it have. So period 1 will have 1 shell, period 2 will have 2 shells. This has no restriction. Period 3 will have 3 shells, and so on till period 7 will have 7 shells. Now here comes the very important question is that why, if you would have noticed, why metals are to the left and why non-metals are to the right. Now this has a very simple explanation. It can be observed that since group 1 has 1 electron, group 2 has 2 electrons, so obviously 1 electron and 2 electrons in the outermost shell, they can be easily given away to become plus ion, and in this case 2 plus ion. So they can be easily given away, and thus these will behave like metals which are giving away electrons. But as you go to the right, then you have 4 electrons, 5 electrons, 6 electrons, 7 electrons, and after 4 the tendency to give away electrons is very, very less, because the tendency to accept electrons is very high, especially in case of 7 electrons. It would take 1 electron instead of giving away 7 electrons. And if it takes 1 electron, it becomes a minus charge. So that is why the non-metallic nature will increase along the period. So that is why most of the metallic elements are towards the left, where there is 1 or 2 electrons in the outermost shell. And as you go to the right, you would have non-metals, because they would have 5, 6, 7 number of electrons, and thus they would behave like non-metals, tending to accept electrons. And you might get questions, a very simple questions from Mendeleev's periodic table. They'll just give you the periodic table, and then they'll tell you to find the formulas of the oxides of Si, C or K or sort of things. And this is not sick. So Si would be SiO2, C would be CO2, and K would be K2O. And you can find it even without looking at Mendeleev's periodic table. Everyone knows it's CO2 and K2O just by taking the valencies. And one very important question, some tricky questions are like, arrange them in increasing order of metallic nature, or arrange them in increasing order of non-metallic nature. Suppose you have sodium, then you have chlorine, then you have fluorine, you have potassium, then you have suppose beryllium, magnesium. If you say arrange them in increasing order of metallic properties, so of course this chlorine and fluorine are non-metals, otherwise all are metals. So just keep chlorine and fluorine separately. They kept keeping them separately. They are obviously less metallic than sodium, potassium, beryllium, magnesium. And out of chlorine and fluorine, which one is less metallic, or in other words more non-metallic? Fluorine, because it is higher, so it has lesser number of shells, so the attraction is more, so it will be even less wanting to give away electrons. So fluorine would be least metallic, fluorine would be also very less metallic but still greater than fluorine. Then we go to these four. Now see, sodium and potassium, they all have one electron each, and this is not boron, this is beryllium. Beryllium and magnesium have two electrons each. So giving away 1 electron is easier, or giving away 2 electrons. Since we have seen that size decreases along the period, giving away 2 electrons would be, the beryllium and magnesium would be comparatively smaller in size than sodium and potassium, because size decreases along the period, and this is period 1, this is period 2. So beryllium and magnesium would be smaller in size. So the smaller in size, the greater is the nuclear force of attraction, and thus the nucleus would not want to let these 2 electrons leave the atom. So they would not behave very as metallic as sodium and potassium. So again, you keep beryllium and magnesium separately than sodium and potassium. Try to do it this way using brackets. Although don't show the brackets, just write the final thing and explain it. So beryllium and magnesium with sodium and potassium. So fluorine less than chlorine less than. Now coming to these two. Now beryllium lies higher in the group, so the one which lies higher in the group is always less metallic because it has a smaller size. So beryllium, then magnesium, and then you have sodium and potassium. Now sodium, again sodium, potassium, sodium lies higher in the group, so sodium would be more metallic. Sodium would be less metallic. Sodium would be less metallic because it is smaller. It lies higher in the group, it's smaller. So potassium has, the electron is quite far away, so it's not really attracted to the nucleus, so it can be lost very easily. So sodium and then potassium. So this is the final order of your metallic nature. And try to do all the questions in this way, using brackets, one by one, step by step, if they ask you about this metallic nature. Okay. So